So thank you so much to everybody to be here. I guess that this is the end of the 2 days of nodes. I want to say thank you to Michael Unger and the whole Neo4j team that organized these 2 days full of great session, great talks. So today we are here to talk about cy2py, which is a seamless Neo4j integration in Python notebooks. And I'm Andrea Santurbano. I'm CTO at Larus Business Automation, which is a Neo4j partner. We are the first partner in Europe and the third global. Our, let me say, love relationship, love story with Neo4j started in 2011 when we did the first spikes, and then in 2014 became solution partner. In 2016 we had the we built the official Neo4j JDBC driver, and in 2018 we did the APAC, the ATL tool, the GraphQL JVM API. In 2019 we built the official Neo4j Kafka connector, and the next year the Neo4j official Spark connector. And we also partnered with Fujitsu, and we built the first AI-based solution on Neo4j, which led us to build our first graph AI platform, Galileo XAI, in 2021. So yes, we partnered, as I said, with Fujitsu, which built the Deep Tensor, a prototype of a deep learning engine with explainable AI that we helped them to productionize, and we included in our Galileo XAI platform. So let's see the agenda, why we are here. We will see how the cy2py integration works, and we do a quick demo. So why? Because in general, notebooks embrace diversity. So please consider these 3 common roles for any data-driven organization. We have the data engineer that can build, for instance, an aggregation table based on trillion of streaming events, and he can do that by using Scala API, Spark, and IntelliJ as IDE. And then from that aggregation table, an analytic engineer can build a streaming report about the streaming quality by using SQL and Tableau. And that report can be used by a data scientist, which can lead him to build a new streaming compression model by using, I don't know, for instance, R and RStudio, or Python and PyCharm. Yes, even if at a first analysis they seems quite different workflow, if we deep dive into them, we can realize that there are 3 common tasks that all of them perform. So they basically run code, they explore the data, and they present results. So, and this is basically what a data science notebook does. It allows to run code, explore the data, and present results via web interface. So this is why data science notebooks became the de facto standard for any data-driven organization, because it's the best environment to communicate the data process and share its conclusion. So how cy2py works? For us, it's, let me say, it's a journey. In Larus, we love notebooks. In fact, in 2018, we built the official Neo4j integration for Apache Zeppelin. Apache Zeppelin is a notebook runner, just like Jupyter, but it's provided by the Apache Software Foundation. And even if we think that Zeppelin is a great product, Jupyter outperformed it, so the market chose Jupyter, and this led us to do an integration for it, so cy2py. This is why cy2py is here. How it works? We basically use Python magic commands and functions. So it works on all IPython-based notebooks, so like Jupyter, the Databricks cloud notebooks, and others. And there are two kinds of magic commands that cy2py allows to use. The line magic, which can be used as an expression, and len magic generally returns a value that can be assigned to variable, and the sail magic, where after is activation can operate on multiple lines below the call. I will show the difference between sail and line magic in the demo. So cy2py is able to automatically recognize if your query returns a graph or a table, and display the data in the proper way. If you use it as a line magic, it will export the data as a pandas data frame if the query returns a result as a table, and as a network X graph if the result is a graph. So let's do a quick demo. The demo is based on the example available on the code repository, so you can go on the GitHub repository. We have the examples, and it's, as I said, an IPython notebook that you can open on Google Colab, so it's very easy to use. So the example is based on the crime investigation dataset from Neo4j. So you need to spin up a Neo4j sandbox just by clicking here. It's a process of very simple steps, so it's nothing so fancy. Then you have to go to the connection details tab and fill the variables here, just like I did. So then you have to run the paragraph. You have to install the cy2py integration from PIP, and once done, you have to load it, and then you can see the arguments that are allowed to pass to a line or a cell magic in this very way, in this simple way. So you have here a set of arguments that you can pass to the Python magic. And yeah, let's use our first line magic. So basically, each magic must be activated by each line magic must be activated by a single %, followed by Cypher, and then you can provide the list of arguments. In this case, we are providing here the Neo4j endpoint, the URL, the username, the password, and then in the end our Cypher query. So this is our Cypher query. And then we simple visualize it. So as you can see here, we have a data frame, and Google Colab renders it properly. But we can also we will also see how a cell magic works. So you can activate it by prefixing with 2% and then Cypher. And then you can write your Cypher query. In this case, we just want to check the metadata. So our graph model. So the graph is rendered by cytoscape. You can pinch in and pinch out. You can click on a node, and you have a tooltip with the properties of the node, the same for the relationships. And yeah, it's quite straightforward, no? So, but as you notice here, there are no colors attached to the label. It seems all very flat. So we want to attach colors to our graph, and you can do that by defining a simple, just an important thing. As you can see here in the subsequent call, I didn't repassed again all the connection properties because they are stored internally. So you need to provide them only the first time. So yeah, coming back to colors, how we can define them, basically defining a dictionary, and in each key of the dictionary, we define the label, and the value is the color. And then you can pass the colors with --co and the colors variable. So let's perform again our call. Oops, I forgot to run the colors. Okay, so, and as you see here, we defined four nodes for the colors, and they are colored properly. So yeah, so in this notebook, as I said in the beginning, is based on the crime investigation dataset, which used the POL data model, which is focused on, which is an acronym for person, objects, location, and events. And yeah, it's used for investigative and security purposes, like counter-terrorism and and so on. So let's dive a little bit into the data by using cy2py. We are writing a very simple query here that basically returns the count of the crimes grouped by type, and we order them. So as you see here, the data is in a tabular form because we return two columns, and is properly displayed from the notebook. You can use the line magic in order to extract a data frame and use other visualization, not only the graph. In this case, I will combine the cy2py line magic with a neat map provided by Plotty, so we can write our Cypher query here, and we activate the line query, the line magic function by passing -q and the query, and then I render the heat map with Plotty. So it just take a few seconds, and here we have our map. So you can use the line magics in order to then extract the data frame and use that data frame in other visualization library like Plot in this case. But you can also visualize graphs. In this case, we want to check if there is a shorter spot between persons related to crimes. I'm not discussing so much about the meaning of the query, because in this case, I just want to focus on the tool and how you can use it. But in this case, we basically return the query, and the query returns a graph, and so we display a graph inside the Jupyter notebook. And in the same way, you can use the line magic in order to visualize, as I did before, in this case, a bar chart visualization. And here we are extracting a graph instead, a very simple graph, in order to identify clusters. In this case, I want to identify clusters of connection between persons that might be used in order to identify gangs or other criminal groups. So we used the line magic in order to to extract. Sorry.
Sorry, Andrea, to break you in between. We are running short of time. We need to wrap it up in next 2 minutes.
I just finished. It's the last
Okay,
bit.
all right, great.
It's the last bit. So you basically can export it to NetworkX and then use the its API in order to compute the triangles and display the results. So that's it, guys. Thank you so much. If you have any question, I'm very glad to answer to them. Otherwise, start the project on GitHub and fill an issue if you need something. Thank you so much.
Thank you. Thanks so much, Andrea. We have 2 minutes, so we can take a quick 1 or 2 questions if possible. So the first question is, where does the cell magic command get the connection details, like URL and credentials, get from?
Yeah, so in the beginning here, I defined 3 Python variables where I stored the connection details, and I used them at the first call here by passing the arguments. So -u, it's the argument for passing the connection URL, -us, it's for the username, and -pw, it's for the password. And then the cy2py integration store this connection details internally, so you don't have provide them each time. Okay.
Cool. One last question: why is cy2py used?
Yeah, basically is used in order to, as I said, to to add Neo4j in your Python workflow. It's something that has a goal to make Neo4j more Pythonic, let me say. So the goal is to gets closer Python developers, so data scientists, data engineer, with Neo4j, with a simple integration that allows to export data in Pandas DataFrame or NetworkX graph in a very easy way. And if you want to also display them, also display the data and build dashboards via Jupyter, you can also use it, using it. Okay.
All right, thank you. Thanks so much, Andrea. I think those are the questions that we had for you, and it's almost time. Perfectly timed well.
Okay.
Thank you.
Thank you so much.
Looking forward to having you next year as well.
See you. Thank you so
you.
much for
Bye.
your time.
Take care.